All right. So what I'm going to do right now, I'm going to design a database schema. I'm going to actually create the database using raw SQL. I'm going to insert data into it. I'm going to query it as well. So we're going to go through that entire step or that whole entire process. I'm going to use this quick database diagrams to design a school kind of database, but that only consists of, addresses, guardians, and students. So if when you go to school or in high school or whatever, um, the school keeps track of each student's guardians, and a guardian can belong to many students because you might have a sibling that goes to the same school. And those siblings can live at the same address, kind of how we talked about before. So in here, I'm going to create 3 tables: an addresses table, a guardians table, and a students table. So I'm going to create addresses just right there. Let's do guardians right there, and students. And feel free to stop me at any time if you have any questions. So addresses, I'm just have an ID of primary key, and this is an integer. We have line 1, that's a string. Line 2, because people live in apartments like I do. We have city. We can have that be a string just to keep things simple. State, that's a string as well. All right. So where are we going with this? So now with guardians, we can have, again, our guardians have an ID, primary key, integer. We have the name, that can be just a string. Phone, let's have that be a string. Email, string. And then a guardian, I don't know. So should a student, let's think about this. Yeah, I'm just going to have the addresses, the address ID associated with the guardians. Because, yeah, that's just because that's how I'm going to design it. So addresses dot ID. There we go. Questions? What questions do you have?
So I noticed on the bottom where it says no errors found, good job. Do you reference that, or you just in your head, you know what you're doing?
Right. I think the errors are just associated with this application. So if I did, looks like addresses ID, but if I did like dot invalid relationship, the field addresses is missing. I think that's just associated with this application running this aspect of it and trying to convert it to SQL. And that SQL, if there's any errors in that SQL, it'll error out down here. And I'm just literally only doing this just to get a visual representation of my database. And it has nothing to do with actually putting out the correct values of the application. I'm not really referencing this at all. But if it does error out, I'll see kind of like what the issue is. It's literally just if there's any errors in the application. ID, primary key, integer. And again, you can use this using a white piece of paper or anything you want. I'm just using it, obviously, because it's a good visual tool for designing a database. So students, what should the students have? Name, string. What else?
Guardian ID.
We can have the guardian ID. Maybe I'm going to have a grade they're in. so
Guardian ID might want to be a join table, multiple guardians.
so they can have multiple guardians. You can do that as well. But for this case right here, I'm just going to keep it at just have one guardian who's the main guardian. But yeah, that's a good point. So, you know, a student can have multiple guardians. But for this example, I'm just going to keep it with one guardian just to keep things relatively simple. So guardian ID, integer, foreign key, guardians .id. All right. Do I need anything else? Maybe like date of birth. That's a date. All right. So questions, what questions do you have about just the simple database schema?
The students want to need an address ID because it's connecting to the guardian's ID. Is that correct?
Exactly.
Gotcha. Okay.
Yep. And that's just a decision I made. I could put the address ID here. So I could put the ID there as well. But this is the decision I've made for this one. All right. So with that, I'm going to go ahead and actually create this schema. What am I looking at? Oscar challenges. I'm going to open up update later. I'm going to create clear. I'm going to list everything out. I'm just going to make a directory called SQL example. CD in a SQL example. All right. I'm going to open this up into a new VS Code window. I'm going to create that schema. I'm going to load it into my database, and I'm going to create some seed data, and then I'm going to perform some queries on that. All right. So in here, I'm going to create a example schema.sql file. There we go. And I'm going to copy this over. What the hell is this stuff? Like so, and just comment that out. Close the VS Code window and go ahead and create these the addresses table, guardians table, and students table. So I'm going to create table, addresses, and we have an ID, serial, primary key, What else we have? Line 1. Let's do that. Make that a varchar 255. Let's have this one not null because you need a single, at least one line. Make this a varchar 255. And this is optional. Is there a way I can add like a default value to here instead of have it just be blank? Does anybody know how to add default value?
It's just default the keyword.
That's it. That was like default equals something or something like that.
So here's an example. So default, and then whatever that value is. So I'm going to have just the default to null, just in case no one puts anything in there, it just defaults to null. city, varchar, just for whatever hell. I'm just gonna make it 100 because I don't know how long cities are. I'm gonna make that not null. And then state, varchar. I'm gonna keep that simple, just 2 letters, not null. I think there's usually a zip code as well. Zip code. I'm gonna make that up there. Zip code. I'm gonna make that a varchar. I'm gonna have the constraint to be 5. I don't want them to put the dash, whatever. I'm also gonna make that a not null. I'm gonna add all the commas, and always don't forget to add the semicolon at the end of addresses.
Quick question with the default keyword, if they didn't enter anything, wouldn't it be null regardless? So is default to null kind of the default?
I actually don't know, but I always explicitly, if I want a default value, I explicitly tell SQL what value that should be.
Got it.
Could also be like false or whatever, or not. But I always explicitly define what that value is. All right, we have addresses. Now let's look at guardians. So create table, guardians. Nice. What do we have? ID, serial, primary key, name. Let's do varchar. I'm always going to make that 255, not null. What else? Phone. Phone number, varchar. What is 369? Let's do 10. That includes like the +1 or whatever. I'm going to make that not null. Or actually, let's make that just empty. So it could be empty. Email address. Maybe, for example, we must require an email address. Should make that 100. I'm going to make that not null. And again, these are just decisions on, these are my decisions. There's not necessarily, you can make the phone number not null as well if you want, but I'm just going to make this not null or make it able to be blank. And then we have address ID. Address ID. So since I'm creating my addresses table before I'm creating the guardians table, I'm just going to do it on a single line. I'm going to make it an integer, references, the addresses table. And you can reference, you can put what column you want it to reference. Like, hey, maybe I want the foreign key on here to be city. That's generally not good practice. You want to reference the ID. If you don't put anything down, it defaults to referencing the primary key. And lastly, let's do the students table. Create table, students, ID, serial, primary key, name, it's varchar, which again default to 255. Make that not null. Grade, like what grade you're in, varchar. Let's make that 2 or. Yeah, 2, because you're like 12th grade. You're not going to be in a grade that is greater than 2. And date of birth, you can do DOB. Does anybody know the date? Is it just date? Is that the right date SQL data type? So, all right, the date looks like I want it. That works. So I'm just gonna do date. I'm gonna make this not null. And guardian ID is integer. References guardians. I'm gonna add a semicolon at the end of those just to make sure. What questions do you have about creating these tables?
I just didn't know the references addresses. You can use it like that. I don't know if I didn't know that would work. Yeah, actually put in like the addresses at ID.
Like so?
Yeah.
Yeah, you can explicitly tell what column to make this foreign key look at, or I believe you can just do addresses and it will automatically reference the primary key of the addresses table. But we'll test it out. We'll run it and see if that works. Maybe it does, maybe it doesn't.
If the tables are in separate schemas but in the same file, would the syntax change at all if you're referencing foreign keys?
If they're in like a separate file?
Yeah, for example, if you say had one schema for just the addresses, one for guardians and one for students, and if you wanted to reference each other, would the syntax be the same or would that have to change?
That's a good question. I actually don't know. I think it depends on maybe the order that the files are ran. So as long as the table exists in the database.
If you're
when
going with
running a
that
file.
away, I'd suggest like you do all your create tables and then you have a final like alter table where you generate all of your constraints and foreign keys.
Okay.
So at the very top, I'm going to drop the table if it exists. What is it? Addresses. And I'm going to do cascade. And then I'm going to copy that one down. Guardians and students. All right. So I designed the schema. Where'd it go? I created the schema in raw SQL. Now I'm going to create that database. Create DB. I'm going to call Oscar Platoon. All right. PSQL Oscar Platoon. Cool. So I can inspect it. There's no relations. Now I can go ahead and run this by, I can do /I and then example schema. All right, cool. It dropped the tables if they existed, and then it created the tables. Now I can inspect all the different tables. So we have the addresses, guardians, and students. Now I can inspect the addresses table. Great, not null. And then guardians, just inspecting each table. Great. Does anything look cool? All right. So I'm going to clear the screen or clear the terminal. And now I'm going to touch a seeds or seed.sql file and code seed SQL to open it up right here. Now let's go ahead and create some seed data. All right. So first thing I'm going to do is I'm going to create some addresses first because the guardians, I can't create a guardian. Well, technically I could if it's not null, but I'm going to create some addresses. Let's create 3 users or 3 addresses and 3 different users or 3 different guardians. All right. So how do I insert data into the addresses table? What's the query?
I know you start with insert.
All right. Insert. Does anybody else?
And then you have to include the columns that you're going to provide data for by name.
All right. So I'm going to insert into addresses, the name of the table. And I need to include all the different columns that I need. So for this one, if you don't include the ID, it automatically starts at 1. So if I don't include the ID, which I'm not going to do here, I'm just going to include line 1. I'm not going to include line 2 in here. I'm going to include the city. I'm going to include the state, and I'm going to include the zip code. So I'm skipping over the line 2. So I'm going to insert into these 4 columns the values. Now here, the order of this counts. So whatever first value I put in here is going to be inserted into line 1. So I can do a string of 125 South Clark Street. So there we go. I'm going to make that a little bit bigger. South Clark Street. The city, it's going to be Chicago. State, Illinois. Zip code 60605, or I think it's 60603 or something. I'm going to create 3 more addresses. I'm going to 123 West Real Street 60605 and 555 South Fake Street 60119. I don't know. 60091. All right. So I created 3 addresses. Let's go ahead and run this. So I'm down here in the terminal. I'm going to clear the screen. I'm going to PSQL Oscar Platoon. Insert into angle bracket insert, like I'm pushing something into the Oscar Platoon database. Seed
You're gonna
SQL.
have to fix that PSQL.
Oh, thank you. PSQL. Database Oscar Platoon. Didn't spell Oscar Platoon right. Platin. Let's see if I got one right. Finally got one right. All right. So I can PSQL Oscar Platoon. And now I can do select star from, what is it, addresses, and just see if they're all there. Great. So quit, clear. Now let's go ahead and create some guardians. So insert into guardians. So in here, what do I need? A primary key. All right. So in here, I didn't include the primary key, but you can include a primary key if you want to. So if I wanted to explicitly say what ID it was, I can do that. So I'm going to do name, phone number. I'm just going to add everything in here. Phone number, email, address. And here, I knew the address ID, so I can explicitly insert into what address this guardian belongs to. So values, I'm going to just start at 1. Name, Sarah Connor. The phone number, 555-222-1234. Email address, sarah@email.com. And address ID, let's make them live at address 1. create a couple more. 2, Ruthie, Cohen. Let's make them live at address 3. And 111-555-9876. And last one, Tom Preet, make them live at address. Whoop. ID should be 3. 555-456. There we go. And Tom at email. Yep.
So for Ruthie, should your 3 be a 2 on line 11?
Right there.
Yes.
So here I'm just associating what address this person should live at. So I'm explicitly
gotcha, okay.
saying, hey, I want this person to live at 555 Fake Street, but I could put this one, they could all technically live at the same address, but that's not realistically for this specific scenario. So I'm just kind of mixing it around so it's not all one-to-one. So 3, and then this Tom is going to live at Real Street. So I can Python, let's see, what am I doing? Not Python. So let's see that data. Oh, that's, okay. Interesting. Let's see. I'm going to run this. So I inserted the seed. I ran the seed file again. So let's go in there and then select star from, select everything from the addresses table. So it looks like I made duplicate entries right here because I ran this file twice. I inserted everything into here. Once I ran it, and then I ran it again, and I inserted everything again, so it just made duplicate values. So what I'm going to do, just because, oh man. PSQL, I'm just going to drop the database, see the data again, and then we'll run some queries on it. PSQL, school, Oscar, Platoon, insert into example schema. So it dropped the database. And now I can see the data. Great. Let's PSQL, Oscar, Platoon. All right. So let's start querying. I wish I can. Oh. So I can select star from addresses, just make sure that those are all in there. Great. Select star from guardians. And now I've got guardians in there. So if I wanted to know what address Tom lived at, let's write that out in here. So if I wanted to, so if I wanted to get the address that Tom lived at, so I'm right here. How do I go? What's that query look like? Just write that right here on line 16 or.
Be select address from whatever database you're in, and then where name equals Tom.
So select addresses from, so say that one more time.
Select address ID. Oh, I'm sorry. So it'd be select let me think about this.
So I want to start at the guardians table. That's just where I'm going to start. But I could start here, but it just depends on. But I want to start at the guardians table and grab Tom's address from the addresses table. So I'm going to select everything from the guardians table. And then, so I grabbed everything from the guardians table. Now I want to join the addresses table. So I'm going to join the addresses. So I'm joining the addresses table, and I want to know where do I want to actually have those like stitched together. So on addresses ID equals guardians dot address ID. So I'm stitching, essentially overlaying these two, I'm combining these two databases where the address ID and the addresses dot ID equals the address underscore ID. All right. So I'm just going to run this. I just want to see if anything comes out. So I'm going to click clear. So cool. So notice, so I've joined both the addresses or both the guardians table and the addresses table where the address ID equals the guardians dot address ID. So I'm combining those two tables right here. But I want to, I'm sorry?
So that's an inner join?
Yeah, if you just do join, I believe it defaults to an inner join. So, but I want to know where Tom lives. I want to just grab Tom's address. So I can do, hey, where? So I'm joining these addresses, which is right here. But I'm saying, hey, where guardians dot name equals, I'm going to do Tom Preet. So this query joins both of those tables. And now I'm saying, hey, only display where the guardians dot name equals Tom Preet. So come over here, print that out. Whoop. Uh-oh, what happened? Error column.
Single quotes.
Yep. So you can't use double quotes. It must be a single quote. So let's do that. Single quote. There we go. I've got my name, phone number, email, address, ID, and now I know where Tom Preet lives at 123 West Real Street.
Wait, did it try to interpret the double quotes as another column?
I actually don't know. It's a good question.
That sounds like a terrible idea, but that's good to know that you could make your column names something in quotes.
Now you did select from guardians, but if you wanted just to return the address, that's the only information that you had. You could, I'm assuming you could do select from addresses and then join the opposite direction and search the name.
So I can do the same thing here, but if I did addresses, whoop, and join guardians, let's see what this looks like. Now the tables are just switched. See that?
Yeah.
But I'm going to get rid of this one. But maybe, as you said, I just want the addresses. So in addition to this, so maybe I just want I'm selecting everything from the Guardians. I'm joining everything, but maybe I just want the addresses from this entire table. So let's see if this actually works. So I'm going to quit, clear, go back in. So I'm selecting just the addresses from that entire big table. Now it looks like it comes in as a tuple, but it still shows me just the addresses. So there's that way, but maybe I just want, the Guardian name. Maybe I just want it to just display, Tom Preet and the addresses. So I can do select Guardians, Guardians dot name, comma, addresses dot line 1, comma, line addresses line 2, comma, addresses city, state. Now see, I'm like, it's a big query, zip code. And now I can pretty much do the same thing from Guardians. So I'm just grabbing the Guardian's name, address line 1, 2, some from that. So if I run this big query, let's see what it returns. Tom Preet, Real Street. Cool. I can kind of simplify that. By doing addresses star to grab everything in the addresses table. So this should essentially be the exactly same query as the one above. Uh-oh, what just happened?
Yeah, I think you need the from statement.
From, oh, did I delete that? Yes,
Yep.
I did. So get rid of all that. Queer, I'm just gonna clear this. Now I get the same thing.
So in the line above where you did addresses on line 22 and it returned a tuple, if you did dot star on that, would that be a table?
It's a good question. Yeah, let's do that. So it's pretty much the same thing as this one, just minus the Guardian name, the Guardian's name. So there's Tom Preet's address. Cool. Let's quit that. So I've got, 4 different queries with a single that utilizes a single join table. But now let's go ahead and add some students in there. So insert into students. Name, grade, DOB, and Guardian ID. The values, we can say, what do we want in there? Let's just say Mike, ID, or what is this, grade? Yeah, grade, let's say 7. So here, the date, we actually have to put it in the correct format. So I'm just going to say 2005 -01 -28. And the Guardian ID, let's hard code that to 3. And let's do the same thing down here. It's Joan Greenwood. Let's say 5 and say 2010, 03, 04, and let them have the Guardian to be Tom as well. So I can either run this file again, or I can literally just kind of copy this in here and directly put it into the database like so, because I don't want to drop the database again. Great. So it looks like for the name, I don't have a last name, but just for this example, let's go ahead and update Mike to have a last name. So we can create a query to update. So we can say, hey, update the students table, set name equals Mike Preet. So we're updating the students table. We're setting the name to equal Mike Preet. And we're saying, hey, where do we want to set that to? Where ID equals what ID is Mike. So it looks like Mike's the first one. And we can run that by select star from students. So we want to update Mike. So where the ID equals 1. We can come down here and run that. So it updated 1. Now if I select star from students, now you notice Mike has a last name of Preet, but nothing else changed. And don't worry about this order. That's just the way it doesn't actually change in the database. So if we're there, let's do 2 more queries. And then we'll let you go to lunch. So if I wanted to know all the students who has a Guardian name, or I want to grab all of the students who is the Guardian of Tom Preet. How do I go about, what would I do?
Select students from Guardians where
Select students from Guardians. All right. So this is assuming I'm going to need the students table at some point. Is that correct?
Name from students.
So I can say select maybe students.name from students, I heard. So I'm just grabbing the student's name. I'm starting here in this table and I'm grabbing the name. Now, what table do I need to bring in? What table do I need to join?
And you could join Guardians on those.
So join Guardians on, where do I want it to like stitch together? Where the Guardians, the students dot Guardians ID or Guardian ID equals the Guardian dot ID.
Yep.
All right. Where students dot Guardian ID equals Guardians dot ID. Now I said I want to grab the students' names who belong to Tom Preet. So I can say, hey, where Guardians dot name equals Tom Preet. So let's actually just first bring in this table. So I'm just selecting all the students from the students table, and I'm just joining where the guardian or the students dot guardian ID equals the guardian's ID. So it should probably list out all the guardians table and all the students table. Oh, actually just, oh yeah, because I'm just selecting the student's name. So I'm literally just selecting all the students in the database. But if I had guardians or select star, if I did that, it would have everything. But I'm just grabbing the name. So now I'm grabbing all the students' names, but just where Tom Preet exists. So it's the same thing, just because these two students. So if I had like another student that was a guardian to somebody else, they wouldn't show up. What questions do you have about the join tables? The join tables are the thing that students have the biggest, have the most trouble kind of get understanding.
Yeah, it's pretty hard to visually parse the statement to figure out what it's going to have.
Yep. That's why I do kind of baby steps. Do one query. It's like, okay. So we have one join table, but maybe I want to get the address of Jane. So we've got Mike Preet. Let's get their address. So I'm starting with the students table, and now I have to bring in the addresses table somehow, but I have to go through the guardians table. This is where things get a little more complex. Not necessarily more complex, it's just you're joining more tables. So I need to select addresses. So I'm just going to grab everything from the addresses table. From addresses. So here I'm going to start from the addresses table. I'm going to see where Jane or where Mike Preet lives. So I'm going to join the guardians table on where the address is .id equals the guardian .address ID. Okay. So if we did that, let's just quickly look at that, see what that shows us. Uh-oh. What just happened?
Wouldn't it just be select star from addresses?
Select.
I think you have a typo in that first addresses.
Thank you. So if I do that, cool, I get all the addresses. But now, but if I did select star, let's just do select star just to keep things so you can see what that looks like. So there I've got the addresses and the guardians. But what if I also wanted to join the students on where the students dot guardian ID equals the guardians dot ID. So I'm bringing in all the students now as well. So let's look at what this table looks like. A big long table that has the addresses, the guardians, as well as the students. And you can actually do, to make it a little more visually appealing, if it's a really big query. So I did \x. It's called the expanded display is on. So if you have a big long query, this one actually happens to be able to fit on my screen. But if I had a smaller screen and it wrapped around, I can do the display and it just puts it in a different format. You can kind of see it a little bit better almost. So that's called the extended display. But everything fits on my screen like this, so that's fine. So,
So I just have a quick comment. Now that you've showed the app.quick database and now that you're doing this, my mind just exploded because just of the possibilities. I was like, oh.
Yep. So now I wanted to, what did I want to do? Get where Mike Preet lives. So now at the very end, I can say where students dot name equals Mike Preet. And I'm just gonna quit that, clear, come back in there. So select everything from addresses. I'm joining the guardians table, and then I'm also joining the students table. And I'm saying, and you can't, and where the on part, it has to be where those two tables, where they're kind of linked together. And I'm saying, hey, where the students.name equals Tom or Mike Preet. And now I can click enter. And now I get all three tables of the guardian, the student, and the address. But I just wanted the address. So I can actually just put addresses dot star and run that. And now I get specifically where Mike Preet lives, but maybe I want it to also have, students.name in there as well. So when I display this, I know like what the student lives there. So I'm adding the students.name, Mike Preet, ID. I also kind of want to show you another thing. So typing out addresses every time is kind of cumbersome, or it can be cumbersome, especially if you have a column or a table that has like a long name. So you can have abbreviations for these tables as well. So I can say, hey, from addresses, as add. And so anytime I reference the addresses table, I can replace with just a shortened abbreviation of that. So I come over here, and now I'm just using that ADDR for short for address everywhere I'm referencing the addresses table, and it should still work. I can do the same thing with guardians. Join guardians as guard. And now anytime I reference the guardians table, guardian, guard.address ID, guard.id, I still get the same thing. Likewise with students. So join students as stud. And now anytime I reference the students ID or the students table, I just can use STUD as an abbreviation for the students table. And I get the same thing.
And that is confined to the single statement, right? Like outside of that statement, you couldn't refer to.
Correct. Now, for example, what if I had another table on here, like as like classes, and I had and like students had like a class or whatever. So I'm just saying you can keep on adding tables onto here, and you can keep on joining. You can make multiple join tables. So you can keep on adding join tables. So, so this is a double join, but you can have multiple join tables, like 3 or 4 or 5 join tables connected, depending on how complex your schema is. So I would really get to know join tables, wink, wink.
Hey, Tom,
Yep.
can the table join itself?
Can a table join itself? I do not know. You want to try that out? I'm going to stop the recording right now.